Start recording. Okay. Across AB, BC, and CD. So check properly. Where is AB? Then where is BC? Then where is CD? So first of all, find out common current. That is total current. Then you can think of it, how to get these values.
Sir, across A to B?
What are you saying? Across A to B, what? What's the answer?
It is 3 volts.
Across AB is 3. Okay.
BC is 1.5.
1.5. What's the total current, by the way?
1.5 amperes.
1.5. Okay.
Right, sir?
Okay.
Is it right?
What about CD?
Sir, CD is 7.5.
7.5. Okay. Let me just check.
Is my answer right?
I don't know. Let me check. Yes, CD is 7.5. BC is 1.5. Yes. And AB, what's AB you said?
3, sir.
Yeah, correct.
That.
Very good.
Thank you.
What about others? You don't use calculator, right, Kavya?
No, sir. No difficult calculation here. Like all calculations are easy.
Easy only, right? Okay, good.
Yes, sir.
Okay. Aditi, you tried?
Yeah, so I just did a small mistake in calculation. I'm just getting the answer.
Okay.
Sir, I'm getting C to D answer different, sir.
Okay. What is it?
Sir, I'm getting 8, sir, because like at the D it is 9.5.
Okay. You're getting 8. Okay. I'll solve it. Don't worry. But I just want you to try. You all to try. Okay. It doesn't matter you get right or wrong. It's not a problem. What about others?
Or I'm getting the same answer as Sharanya.
Oh, it's same. Okay.
I'm trying.
Okay. What about Bhumika? Krishna?
Yeah, sir.
I'm trying.
Okay. Yes, Krishna? You got anything?
Sir, I didn't what I'm doing.
Okay. Dipshika? Harini?
Just
join the class. I'm just doing.
Oh, you just joined class. Okay, okay. No,
Yes.
this is our first question. So you didn't miss anything. I gave this question. I'm waiting for the answers.
It's okay.
Modita,
Yes, sir.
any answer you got? VA, VB,
Still-
out of it.
No,
Okay.
sir, still doing it.
Okay, good. Keep doing. For now, Ritvik, Mohit, I guess you joined just now, right?
Sorry, sir.
You just joined, right?
Yes, sir. I joined a while ago.
Solve this question. Then I'll
Okay,
ask
sir.
you answer.
Yes, sir. So I'll solve it.
Sharanya, what you got this 8, right? So how did you solve this? The third one, VCD.
Sir, at the C it is 1.5, sir, and at the D it is 9.5. So if we subtract, we'll get 8, sir.
But why did you subtract? See, easy way to find out voltage across CD is, first of all, find whatever, not CD or AB or whatever it is. I'll give you a hint to everyone. Find out first resistance across AB. Then resistance across BC is already there, only one. Across CD you find out. Okay. First thing you do that, common resistance. Means it should be only one resistor. Here we have 3, 2 in parallel and 1 in series. So solve that, simplify that. Across
5.
AB, you are getting 5. Okay, whatever. Then simplify for AB. And in one side, you find out equivalent resistance to find total current. Use the total current in all this. That's it. It's very simple. V equals to IR. So VAB equals to I common into R. R is AB. RAB. Same way RBC, RCD. You will get answer. This answer is just 3-4 lines answer, not a big answer. Ujjwal, any progress?
Sir, I'm not getting the answer.
Not getting? Okay, no problem. Yukta? Okay. Try.
Sir, one question, sir.
Yes.
So instead of attaching 4 ohms resistor in parallel, can we directly attach one 2 ohm resistor in series?
I didn't get you. Which one you're saying?
Select for the first one, and why do we need to connect in parallel circuit, sir?
Okay.
When we can connect 2 ohm resistor in parallel.
Okay, I'll just give you a remote control. You just show me there. Yes, Kavya, you can show me there. Click on pencil so you can draw.
Yeah, sir. Can you hear me?
Yeah.
So I'm saying this one, sir. Why is it? Why do we have to connect in parallel, sir? Can't we directly attach an 2 ohm resistor in series?
From where you will find that 2 ohm resistor?
So like,
Draw and show me, na, bache?
no, sir. Here we have connected 4 ohm 4 ohm resistor in parallel, right?
4 ohm resistor in parallel.
In parallel. Yeah. So the total equivalent
Resistance will be 2.
resistance would be 2 ohms.
Yes.
Yes, sir. So can't we directly attach one 2 ohm resistor in series?
Yes, that's what we are doing, right? 1 ohm. Then here, what is equivalent of 6 and 12? 1 by 6 plus 1 by 12, it is 3, right?
Yes, sir.
3 and here 1. That is what we have to do.
Okay, sir.
This is what we are going to do.
Yes.
Okay. Okay, guys. I gave you enough time. I will solve now.
Sir, it should be 4, no, sir, instead of 3.
Is it 4?
Yeah,
Yes,
sir, should be
1 by 6 plus 1 by 12 is 4, sir.
Okay. It will be 4. I didn't solve. I just wrote whatever values. Then let's solve now. This one, it is 2, right? See, I'll solve first each. 1 by 4 plus 1 by 4. Those who don't know, learn it with me now. 2 by 4. I'm talking about this, which is R AB is 2 ohm. Then RBC, we already have 1 ohm. RCA. So for that we need to, CD, we need to find out 1 by 12 plus 1 by 6 into 2, which is 3 by 12, which is 12 by 3. So R is 4 ohm. Then RCD equals to 4 plus 1, 5 ohm. So finally, what are we getting? This all 1, 2, 3 are in series. This is RAB, RBC, RCD. What's the battery supply? What's the value of battery supply?
12
12,
volts.
sir.
12. So I equals to V by R. So V is 12 by 2 plus 5, 7 plus 1, 8. 12 by 8 means 12, 1.2. Sorry, 5. 1.5 ampere. Now we have question as VAB. I common because it's in series. In series, current same. IRAB, which is 2 into 1.5, which is 3 voltage. Next, VBC equals to IRBC, which is 1.5 into RBC is how much? 1. The next 5. 1.5 voltage. VCD 1.5 into how much is that? 5, which is 5, 15, 5 is 75, 7.5 voltage. Now, if we add 3 plus 1.5 plus 7.5, we should get 12. Are you getting 12? And 0.5 plus 1.5, it's 12. Yes. So our answer is correct. Everyone understood?
Yes.
Everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes, sir, clear.
super. Akshara, you joined just now, I guess so. Right?
Sir, why did we add D in series, sir? Isn't that parallel to C?
No, bache, see, these two are parallel. 12 and 6 are parallel. Now, this parallel is with. This parallel is in series connection. See, there is same connection here. It's going till here. So they don't divert. They don't divert from here. That means it is in series. This
Yes.
combination is series with this 1 ohm.
Yes, sir. Got it. Thank you.
Akshara, make a note of this question.
Okay, sir. Done, sir. I took a screenshot.
Okay. So here is the solution. If you want, or you can try it yourself. Whatever way.
Done, sir.
Okay. Okay, I'm going to show you one simpler way of finding voltage. But before that, let me see resistance of two conductors. Okay. This is good question. First try this one, then I'll show you some other rule. The resistance of two conductors. So this question is very easy if you think it straight. Conductors in series is 40 ohm and the resistance in parallel becomes 6.4 ohm. Find individual resistance. Conductors. You understood what's the question? Can someone give one small explanation?
So there are two resistors. In when connected in series, their equivalent resistance is 40 ohms, and in parallel it is 6.4.
Exactly. So what you will do here?
Sir, we can equate the equations.
Exactly. Equate the equations. Okay, let's see. Try. Do it. Bhargav, you joined just now, or you were there for the previous question? Yes, we didn't. You said anything, Bhargav? Cannot hear. Okay, no problem. Solve this.
Sir, is it 32 and 8?
32 and 8. Yes. It is 32 and 8. Very good. You got quadratic equation? Sharanya,
Yes, sir.
you got quadratic equation?
Yes, sir.
What is that equation?
So like sir, I just got two equations, sir. That a plus b is 40 and ab is 256. So like
Like what? Okay. So you just got that equation, 256.
yes, I got 256 and I found the two numbers.
Okay, you didn't use calculator, right?
No, sir, I just
Okay.
found the two.
Then okay.
Sir, I got 14 and 26.
14 and 26. Oh
Yes.
boy. Our answer is
Um,
correct. It's not 14 and 26, it's 8 and 32.
So like the quadratic equation I got is x square minus 40x plus 256.
X square minus 40x minus 256
Plus 256, sir.
plus 256. I don't know. Let's see.
Yes, sir.
What is your equation? You got minus or plus, Sharanya?
Sir, I didn't use equation, sir. Like I
Oh
got
yeah, okay.
a plus b is 40, sir, and a into b is 256. So I found the two factors of 256 which can add up to 40. So 8 and 32 are coming.
Okay. You did that method. Okay. Good. Nice. Join class. Okay, Bhargav, no problem. You're doing this question, right? Okay. Shall I solve here? Aditi, Akshara, Amatula, Vargav, Bhumika, Krishna, Tipshika, Harini.
Yes, sir.
You got answer? Modita, Mohit, Pranav, Ritvik, Satvik.
Yes, sir.
What about your answers, people? Come on. Yes, Yukta, answers. Got 832. Okay. Others?
Sir, as I said, I got that answer.
Got it? The same?
No, sir, like it's quite different.
Okay. Let me solve and let's check.
I got that.
What is it?
Sir, 32 ohm
32 ohm.
and 8 ohm.
RF
What?
equals to R1 plus R2, which is equals to 40. RP equals to R1 R2 by R1 plus R2, which is equals to 6.4. So R1 R2 by 40 equals to 6.4. So R1 R2 equals to 40 into 6.4, which will give you 6, 4, 64, 16 and 24, 256. 6. Now, from this one, we can start something. Substituting method. So R1 equals to 40 minus R2. You can substitute here R1 value, then get the quadratic equation. (40 minus R2 into R2 equals to 256. R2 square minus 40R2 plus 256, which is equals to 0. So in 256 means,
So then you will get x minus 14 into x minus x plus 10.
yes, minus 40.
14 and 10, sir, you will get 14 and minus 10.
How can you get then 40? I want 40 in this one. Na? See, this sign shows we will add. Okay. We need to add and get 40.
Minus 8 and minus 32.
Exactly. So R2 minus 32, R2 minus 8 R2 plus 256. If we add this two, we will get.
Sir, I did a silly mistake, sir. My quadratic equation is right, but solving it was wrong. Instead of 40, I wrote it as 4.
Oh. So R2 minus 32, R2 minus 8. So R2 can be 32 ohm or 8 ohm. Then R1 will be 8 ohm or 32 ohm. Both can be possibility. Everyone?
Yes.
sir, got it.
Any doubt?
No, sir.
Others?
No doubt, sir.
Okay.
No doubts.
No,
sir.
no,
Even if your mic is not working, you can't speak. So at least you can just do thumbs up. Okay, yeah, understood. So that like, yeah, I can understand. Yeah, you finished writing. Okay then. Shall we move to next question?
Yeah, sir.
Okay, I'm going to solve one method here, but for CBSE it is not there. But for competitive exam it is there. So we are doing it. Potential difference VPQ. Okay, this is four voltage, 2 voltage, three ohm, 1 voltage.
Sir, can you repeat the question?
In a circuit shown, what is the potential difference across VPQ? Means we need to find PQ volt potential difference.
Okay, thank you.
Where is P?
What
Where
is
is Q?
the resistance of PA?
Which one?
PA, sir, PA.
Oh yeah, it is 1 ohm. Okay, for this one, we will use a method called Kirchhoff's voltage law. Kirchhoff's voltage law. Okay, in that, what is Kirchhoff's voltage law? Sum of all voltage or potential difference is equals to 0. In short, if it is resistance, how to make it potential difference here?
Multiplying it by
current.
Yes,
I.
multiply by current, multiply by I. Same multiply by I. Voltage already there, voltage is already there. Here multiply by I. Here also multiply by I. Here voltage already there. So sum of all this in a loop. Condition is it should be a closed loop. it should be a closed loop, will be equals to 0. Okay, I'm doing this question. You see here itself. Don't see anywhere. Okay, I'll write here first. First, in a loop.
So how will we calculate the current?
Yeah, we will do that. We'll do one by one. You see here. In a loop, A, B, or let's follow this side. A, C, then D, P, and A. This we are going to follow first. We are going from A to C, C to D, D to P, P to A. Okay. Now, what does this Kirchhoff's law says? We have to sum of all this voltage. Sum of all this voltage equals to 0. Now here comes the sign convention. We are going to follow sign convention. First, let us divide current now. Now from this junction, let's assume one current I1 is flowing here. I1 is flowing here. See, it's flowing here, here, here. Same I1 is flowing here. Same I1 is flowing here. Okay, this is the junction. At junctions, current divide, right? See, at junction, either current divide or add. At any junction, current either divide or add. This is not the junction. There is no junction here. So it is not dividing or adding. But here, this is the junction. Either it will be add up or divide. So I am following this method. Like, see, it can be, we can start current any direction. Okay. We can start in this way also. Doesn't matter. It won't make much difference here. Okay. So this was I1. So I is flowing here, I1. And in this direction, remaining current, I minus I1. Are you able to understand what I'm saying? First, there is I current is flowing from the center and it is dividing in this one. I minus I1 is flowing on this A to P side, and A to B side, I1 is flowing. I can change, I can interchange also. It's not a big deal. Even I can change the direction of this current also. It's not a big deal. Even I can change direction of this current. I can say current is starting from here. Then according to that, it will divide. Let's say this is I. So it is I1 is flowing here and I minus I1 is flowing here. It won't make a much difference. It is just a sign convention. First, have you understood what I'm saying?
Yes, sir.
Are you able to understand?
Yes, sir.
Okay. Then next. Okay, low battery. One second, please. Let me connect charger. Okay, yeah. So I started current from this one, I. So I is in dividing in junction. In this junction, junction A, it is dividing, and junction C, it is adding. See, then on, see, think it carefully, or listen carefully. See, this at junction A, it is dividing. So I1 is moving here, I1 is reaching here. Now, at C and A, there should be only one current, which is I. Okay, you cannot change that because we have started that way. So at C and A, there should be only I. So now one current is moving from A to P, that is I minus I1. Same current is moving here, I minus I1. Now at junction C, what is happening? They both are joining. Joining means we are adding. So I minus I1 plus I1. Are we getting I? Yes. That means our direction of current is correct. See this? Our assumption is correct. Now, if I change the direction of this one current, then every direction will change. Main thing is direction of current only. If you understand this one, whole sum is done. Everyone?
Sir, I didn't understand, sir. Can you please explain it again?
Okay. See, let me highlight this. See, from this one, I1 is flowing. From this one, I1 is flowing, this green mark. Okay. Now, from yellow mark, I minus I1 is flowing. From yellow mark, I minus I1 is flowing. So at junction,
So what is the I1, sir? So what is I1?
I1 is the current. We give a name to a current I1.
Okay.
We give a name I1 here. Okay, because the I was flowing from here, we started this way. From this 4-volt battery, we are starting a current that is I. This I you can start from 2 volt also, you can start from 1 volt also, it's not a big deal. Understand this, it's not a big deal, like you start anywhere. But summation of like this should be clear. See how I cleared this summation, same way you should clear this summation. Like if I started from this one, 4-volt battery, I started I1. At this junction, it is dividing. So it's dividing means it is subtracted. I is subtracted in 2 parts. From junction A, I subtracted into 2 parts. It is going towards B. It's going towards P. So one current is flowing here, one current is flowing here. But total current is I only. One is incoming, 2 are outgoing. So I gave a name here, I1. So remaining current, total was I. Remaining current is
I minus
I
I1.
minus I1. Remaining current is flowing towards P. And it is completing a circuit at C. So at C is junction is joining for as per my directions. As C junction is joining as per my direction. Now the current are joining. See, that is also called KCL, Kirchhoff's current law. Means at junction C, 2 incoming current. If 2 are incoming, there should be 1 outgoing, right? So this is your outgoing current at C. At A, 1 is incoming and 2 are outgoing. If everyone is outgoing, then who will supply? Right? Towards A, I is supplying current at junction A. And at junction A, that I is dividing. Now at C, current are joining. What is the value of this side? I minus I1. What is value of this side? I1. So if it is join, it will be I minus I1 plus I1. That means IE. Here, I is dividing into I and I minus I1. Now clear?
Yes, sir.
Everyone?
Yes, sir.
Current clear? Then we will solve. It's not yet over. I'm just showing you current first. Step by step we are going. This step clear, everyone? Can you understand now current, how it is joining and how it is dividing? Everyone?
Yes, sir.
Anyone having doubt?
So what is meant by loop, sir? Loop AC, D, P, E.
Loop means if we follow this one, see this is loop A, P, B, C, A. We started from here, we completed here. That means it's a circle
Yes, sir.
or a loop.
Passing in that.
Yeah, because current required a closed loop.
Yes.
It cannot flow in open circuit.
Open. Yes.
Okay. So I hope first step clear. Let's solve them. See, this is new for you. So don't worry, you can ask me again. Let it be silly or let it be good doubt. Doesn't matter. No doubt is good or bad. Doubt is doubt. Anyone?
So what is KVL?
KVL means Kirchhoff's
You wrote KCL and KVL.
voltage law. This is
Kirchhoff's current.
Kirchhoff's current law.
Yes.
Yes, dear. Somebody said, sir, yes. What happened? This other name of Kirchhoff's current law is junction law. Junction law. This law, which we just now discussed, right? Current is adding, current is joining, current is dividing. That is Kirchhoff's law, junctions law. Not a big deal. It's nothing big here. Current is adding means summation of in other way we can write here. Incoming current equals to outgoing current. Understood both KVL, KCL? This was summation of all voltage. Here summation of current is equals to 0. If I incoming current plus outgoing current equals to 0, that means summation of all current equals to 0. That is what KCL. Here we did, see, we added IE plus I1 minus I1 equals to 0. So better way to remember is this one. Incoming current equals to outgoing current. So here how many incomings are there? Only one. So I equals to I minus I1 plus I. Outgoing current are 1 and 2. I. So I will be equals to I. So yes. Okay then. Let's solve this question now. What was the battery here? 214213. Okay. Let me draw again. A, B, Q, P, C. Two voltage, 2 ohm, 1 ohm, 4 voltage, 1 voltage, 2 ohm, 3 ohm. Okay, so how I started current here, right? Okay. I minus I1, here I1. Okay. So in loop A, C, D, no. A, C, D, P, A. A, C, D, P, A, correct. Okay. So summation of all voltage equals to 0. So now sign convention here. This is the loop. Okay, no. Let's make it easier. Okay, let me make more easier. D, C. This, if we go this method, it will be more easier. Okay, A, P will come here, na? A, P, D, C. Okay. Now summation of all voltage. Now our direction is this one, and we are moving in opposite direction. So like clockwise and anti-clockwise, like that. So we are moving in anti-clockwise direction. Current direction is opposite. So that will be minus of resistance. Resistance will be opposite. See, this resistance direction where current is flowing from this one, right? Current is flowing from A to P, and we are moving in anti-clockwise direction. This is anti-clockwise, right? Yeah. This is your anti-clockwise direction, and current is moving from A to P. That means it is opposite to us. You can choose any, it's not a big deal here. I'm choosing it at my own way. So minus 1 into I minus I1. First one, voltage done. Next, we are moving in anti-clockwise direction. That means whenever we are moving in anti-clockwise direction, we are touching this one first, right? This we are touching first. That means it is plus 2. and current direction is here, and we are moving in anti-clockwise direction, or opposite direction of this one. That means -2 of I minus I1. And same goes with the 4-volt battery. Plus 4 equals to 0. I think you got confused, right?
Not much, sir.
Yes, a little confused.
Okay. So let's make more easier. Okay. See, first we move. See our loop. How we are moving from loop A to P, P to D, D to C, C to A. First thing, this one clear? See, I'll go with one step by step. A to P we are moving. In that, 1 voltage is coming. What is that? 1 ohm resistance with the current. It is this one. Second, we are getting 2 volt. I'll come on sign convention. First, you understand this one. Third one, 2 ohm into current. And last one, 4 voltage. This 1, 2, 3, 4 clear? 4 values clear?
So why is it -1 and negative?
Yeah, that for sign convention, I'll come to that point. First, you understand this one step by step. So 4 things clear?
Yes.
4 voltage clear? First is with resistance R1, second one with 2 voltage, third one with 2 ohm voltage, and fourth one is 4 voltage. This 4 things clear?
Yes.
Okay. Now let's go for sign convention. Now we are choosing here sign convention. We are moving in anti-clockwise direction. Our calculation we are doing in anti-clockwise. So you can do clockwise also. It's not a problem. You can change according to yours. See, this is all sign convention. As in our current also, we choose our direction, right? So according to that, you can do. It's not a big deal. If you choose opposite, this all values, all sign convention will change. It will be totally changed. Not a problem. So this I'm moving in this anti-clockwise direction. So when I'm moving, this is our direction, calculation direction. This is our calculation direction. And white color is our current direction. So we are moving for, this is our resistor. Current direction is this one. And our calculation direction is this one. That means they both are crossing each other, opposite to each other. Direction is opposite. So we will take minus sign. And for battery, we are moving in clockwise direction. So whichever direction is touched first, if it is if it is we are moving in clockwise direction, it will touch first here. Okay, this smaller one. So we will take a minus sign, lower potential. Here, if it is touching this one first, we will take plus sign. This is not the rule, but for easy way to remember, I'm telling you this. For our convenience, we are taking this side as a positive. So we started in clockwise direction, in anti-clockwise direction. Okay, so first of all, let's talk about this 2 volt battery. So 2 volt battery, when we are moving in this red color, so this is touching first positive. So we got positive here. Then our direction and current direction is opposite. So -1 into I minus I1. Then here we are touching this 4 volt battery on positive side. So this is 4 volt plus 4 volt. Same goes with current direction is here and our direction is this way. So we are getting -2 volt. Now clear?
Yes.
Everyone?
Yes, sir.
Okay. So simplify this. I'll get 4, 6 and 2i minus 2 minus 3. 3i minus 3i1 equals to 6. This is your one equation. You do same thing here. Okay, it's already 7:10. Do you have any class? Or shall I finish this question? Okay, give me just 2 minutes. I'll finish this question, then you can leave. AC QBA, in that this 2 volt, 2 ohm and 3 ohm, it is 5 ohm, and this voltage, if we apply this one, we'll get minus 5 plus 5i1 equals to 0. So I1 equals to 1 ampere. So if you substitute this value here, 3i equals to 9, I equals to 3 ampere. Okay. Okay, do one thing. This requires some long explanation. We'll do it. We'll continue in next class because we might have some other classes also.
Yes, thank you.